Yes, class. This is the last unit of the computer graphics, 3D object representation, and 3D transformation, 3D viewing, and other. All these topics belongs to 3D, three-dimensional, and you can see previously you have studied 2D viewing, 2D object transformation, 2D translation, 2D scaling. All these were based on 2 dimension only. Here we are going to learn about 3D object transformation. So 3D transformation. So in it, two types of object representation are there. First one is boundary representation. And the second one is space partitioning. Representation. So here we are going to study boundary representation. Okay. So in the first part, boundary representation, we have polygon surfaces. Polygon surfaces. For example, we have this picture, this type of picture. This is polygon surface. Okay. It has many surfaces, like for example, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay. And this part from the back side, from the this is 6. Okay. So this is uh, polygon surfaces. All these surfaces are polygon surfaces, like this is the one surface, this is second, this is third, this is fourth, this is 5, this is 6. All these surfaces are the surfaces of the polygon. So to store the information of polygon surface, we have polygon table. Polygon table. So polygon table is of three types: vertex table, second is edge table, and the third one is polygon surface polygon surface table. Okay, for instance, we take an image or a figure. With this figure we will construct the vertex table, edge table, polygon surface table. So we have we are taking this an example. This is v1, that is vertex 1. This is v2, that is vertex 2, and this is v3 here, vertex 3. All these vertices are the these vertices are the vertices of polygon. This is v5. So all these are the vertices of polygon vertices. Okay, this is the figure. Now we can mention the edges also here. E1, this is edge 1, E2 edge 2, E3 edge 3, E4 edge 4, and E5 edge 5. All these are edges. And E6 edge 6. Okay, so we mention here all the edges. 1 2 3 4 5 6 edges are there. So we are going to make vertex table here. Okay, so for vertex table you can see vertex table. This is v1, vertex 1. Vertex 1, as we are talking in 3D context, so every vertex have three coordinates, that is x, y, and z. Previously all the topics we have covered, all these topics you can see we have two dimension only, that is x-axis and y-axis. Here we are going to study three dimensions, x, y, and z. So v1, that is vertex 1, will have x1, y1, and z1, and v2 x2, y2, and z2, and so on up to v4, up to v5. We have five vertices to v5, x5, y5, and z5. Okay, this is the vertex table. Now we will make edges table, edge table. So we have E1, that is edge 1. So edge 1 is made with the help of two vertices, that is v1 and v2. So we will write here v1 and v2. Similarly E2, that is edge 2. So edge 2 is this, v2 and v3, here E3 is this, v1 v5, and so on up to we have edge 6, that is v1 v3. Okay, now you can also see this figure can also be divided into two surfaces, that is s1 and s2. So surface 1 will have the edges, so that table will called polygon surface table. Polygon surface table. Okay, so s1 and s2, two surfaces are there. So s1 is So S1 surface is covered under the edges E1, E2 and E3. Okay, and S2 is covered under the edges E4, E5, E3 and E6. Okay, these are the edges which are covering this. This table points to edge table points, and this table points to polygon surface table. So all these tables, three types of tables are these, and there are three types of table. So all these table are interrelated. Now we will see polygon equation. Polygon equation. Polygon equation. So polygon equation is equals to ax plus by plus cz is plus d is equals to 0, and x y z is a point on polygon. Okay, and a b c d, these capital letters a b c d are constants here. Okay, so if we want to this equation can also be this equation can also be represented in the determinant form with the help of Cramer's rule. You can also convert this equation into the determinant form by the use of Cramer rule. Basically, what I want to tell here is that these points, how we treat these points on the figure. This is the main motive of the polygon equation I am telling here. So ax plus by plus cz plus d is equals to, if we take x y z, if we put x y z, if we put x y z on this equation and it does not equal to 0, then point is not on polygon. Point is not on polygon. Okay, and if we put all these point x y z in the equation ax plus by plus cz plus d, if if the result come less than 0, then point is inside polygon. Okay, and if these points ax plus by plus cz in this equation, we put these points x y z in this equation and the result come greater than 0, then point is outside the polygon. Outside the polygon. Okay, so this is the polygon surface. There are other types of you can say other types of figures or pictures which we cannot represent in polygon surface. So these type of pictures, or you can say images, come under the polygon mesh. For example, triangular representation, quadrilateral representation. Okay. So these types of figures come in triangular representation and quadrilateral representation. Now the next topic is quadratic surface. Now we will learn what is quadratic surface. This also come in the 3D representation. So this is quadric um, quadric surfaces. So the degree of this equation is of second degree. So the objects you can see, or the which type of images or which type of pictures come under this are: number one is sphere, and number two torus, number three ellipsoid. Three types of surfaces you can say come under the quadratic surface. It is of second degree. So we will learn one by one. So the equation of a sphere, this is a sphere here. So x square plus y square plus z square is equals to r square. R is radius here, and x, y, z are the three coordinates: x axis, y axis, and z axis. uh, where you can see these x and y z is equals to: x is equals to r cos theta, r cos phi cos theta, okay, and y is equals to r cos phi sin theta, and z is equals to r sin phi. Okay, three types of equations are these. So x is equals to this, y is equals to this, and z is equals to this. This is the sphere equation. Ellipsoid. Now second is ellipsoid. The number is changed. Second, you can say second, you can say it second. So the ellipsoid. So in this ellipsoid we have three radius, that is rx, ry, and rz. So 3 points will remain same: x is x, y, and z. These points will remain same, and the radius will be changed: rx, ry, and rz. Okay, and the square of all these is equals to 1. This is the equation of ellipsoid, where x is equals to rx cos phi cos theta, and y is equals to ry cos phi sin theta, same as previous in sphere, and z is equals to rz sin phi. Okay, now the last is the torus. What is torus? Sphere is a, you can say in this sphere is a Solid is just like a solid ball. Okay, it is a solid ball. And torus is you can see we have a circle, we have a circle, and we move this circle round with a respective axis. So if we move this like, so it will move like this, and it become the torus. You can see torus, and the plural of torus is tori, tori, tori. So this is torus. Okay, so this is your torus. So this circle is moved like roundwise. Okay, and the ellipsoid is this. You must also know that our earth is in the shape of ellipsoid. Okay, we have three x, you can see it as z. This is x-axis, this is y-axis, this is a, this is c, this is a. These are the radius. So here these radius are equal, so you can say these are a and a. These all radius can be differ from each other. So this is ellipsoid, and torus is this. So in computer graphics we have equation for that. So the equation for the torus is r minus, that is radius minus root x upon rx whole square plus y upon ry whole square plus z by z upon rz to the power whole square to the whole square is equals to 1. This is equals to 1 is outside the root. Okay, these whole is in the root. So this is the equation of torus, and the plural of torus is tori. We also have a parametric equation for this. Parametric equation, x is equals to rx r plus cos phi cos theta, and y is equals to ry r plus cos phi sin theta, and z is equals to rz sin phi. So these are the three equations. These are the three equations for the so two topics have been covered. One is polygon surface, and the other is torus, and sorry, and the other is quadratic surface. So I think these topic might be clear to you. So have a look. Thank you.